Hello everyone, welcome back to my channel. In today's video, we are going to discuss a very important previous year questions from coordination chemistry, most importantly metal EDTA complexes. We will move to the first question. This question has asked in CSIR NET December 2018 Part B 2 mark question. Let's see the question. For magnesium complex of EDTA 2 minus, the number of nitrogen donor and oxygen donor centers are respectively option 1, 2 and 4, option 2, 2 and 2, option 3, 2 and 6, option 4, 2 and 8. Let's see the solution. For magnesium complex of EDTA 2 minus, EDTA is EDTA means ethylene diamine tetraacetate, that is a hexadentate ligand. It donates through 2 nitrogen donor atoms from 2 NH groups, 4 oxygen donor atoms from 4 COO groups. So total donor atoms is equal to 6, 2 nitrogen plus 4 oxygen. Therefore, the number of nitrogen donor and oxygen donor centers respectively 2 and 4. So, correct answer is option 1. We'll move to the second question. This is asked in CSIR NET December 2015. Among the following complexes, which are chiral? Option A, COOX thrice 3 minus. Option B, trans CoCl₂ plus. Option C is chromium EDTA minus. Here the correct set includes the EDTA complex chromium EDTA minus. First we'll see what is chirality. A complex is chiral if it does not have plane of symmetry and it does not have center of symmetry. It forms non-superimposable mirror images and it shows optical isomerism. Let's analyze the option. Option A, COOX 3 minus. Here OX is equal to oxalate C2O4 2 minus. It is a bidentate ligand. 3 bidentate ligands is 3 bidentate ligands in octahedral complexes forms delta and lambda optical isomers. So it is chiral. Next is option B, COEDTA minus. EDTA is obviously a hexadentate ligand and it forms octahedral complex. Rapid arrangement produces delta and lambda forms chiral. So it is chiral complex. And option C, trans CoCl₂ En2 plus. En is equal to ethylene diamine, that is bidentate octahedral complex. In the trans form there is a plane of symmetry. This is a chiral. Only the cis form of CoCl₂ En twice plus is chiral. So final answer is A and B. We'll move to the question. Here option A is the correct one. A and B is the correct answer. We'll see the third question. Before moving to the third question, we'll see the quick important rule. See, 3 bident ligands in octahedral geometry is always chiral and EDTA complexes usually chiral. Transform also usually a chiral. Cis with chelating ligands is often chiral. Next, we'll see the question. It has asked in NEET 2021. Ethylene diamine tetraacetate EDTA ion is option A bidentate, tridentate, hexadentate and unidentate. The correct option is option C hexadentate because it has 2 nitrogen donor and 4 oxygen donor atoms. So total 6 coordination set. We'll see the next one. Each complex has a coordination number of 6 for the metal centers. Option A FeCN6 3 minus, chromium EDTA minus, CuNH3 4 2 plus. nickel Cl4 2 minus. We'll analyze the options. Option B, chromium EDTA minus. EDTA is a hexadentate ligand. It binds to 6 donor atoms, 4 oxygen plus 2 nitrogen. So coordination number is 6. And option A, FeCN6 3 minus. Here Cn minus is a monodentate ligand. 6 Cn minus ligands attached. So coordination number is 6. Next is option C, CuNH3 4 times 2 minus. NH3 is monodentate, 4 NH3 ligands. So coordination number is 4. Though Cu2 plus can sometimes have elongated octahedral geometry, here only 4 ligands are shown. And option D is nickel Cl4 2 minus. Cl minus is monodentate, 4 ligands. So coordination number is equal to 4. That is usually tetrahedral. So correct answer is A and B. Both have coordination number 6. We'll see the question. See, in this question, FeCN6 3 minus and chromium EDTA minus. Option A and B is the correct one. Next, we'll see the fifth question. In the complex formed by EDTA and the divalent metal ion M2 plus, the EDTA ligand occupies how many coordination sites? 2, 4, 6 and 8. That option C, 6 is the correct answer. In EDTA complex is always EDTA complex is a hexadentate ligand. We'll move to the next one. Which of the following statements about EDTA complexes is true? Option A, EDTA is a monodentate. EDTA can lead to octahedral complex. EDTA cannot displace water ligands. EDTA always forms square planar complexes. Correct answer is option B. EDTA can lead to octahedral complexes. We'll see the next question. The complex Cu-EDTA minus is paramagnetic and chiral, diamagnetic and chiral, paramagnetic and chiral, diamagnetic and achiral. Correct option is option B. We'll see this question in detailed form. Step 1. Oxidation state of Cu. EDTA ligand charge is 4 minus. Overall complex charge is equal to minus 1. That's oxidation state of Cu is equal to X. X plus minus 4 is equal to minus 1. So X is equal to plus 3. So metal ion is Cu3 plus. Next, see the step 2. Electronic configuration of cobalt Z is equal to 27. Co electronic configurations A are of 3d7 and 4s2. Co3 plus removes 3 electrons. So it is 3d6. So configuration is d6. Step 3. Geometry and spin state. EDTA is a hexadentate ligand. So it occupies 6 coordination sites. That is octahedral complexes. Co3 plus is a high oxidation state metal ion. And EDTA is a relatively strong field ligand. Forms low spin octahedral complex. Low spin d6 configuration in octahedral field is d6-2g e0g. All electrons are paired, so it is diamagnetic. In step 4, we'll see the chirality. Even though EDTA is not symmetric like oxalate, when it wraps around the metal ion in octahedral geometry, it produces delta and lambda forms. So Co-EDTA minus is chiral. So option B, Co-EDTA minus is diamagnetic and chiral. Option B is the correct one. If this explanation helped you, please like the video and subscribe to my channel for more CSIR NET, GATE and BARC chemistry content. Thank you for watching. If you want any other topic, please comment below.